We will start the question. It contains one linear term. So we will write it as a over x minus 1 bx plus c over x square plus 1 and dx plus e over x square plus 1 whole square. So this is the requirement for breaking a partial fraction having quadratic term in the denominator with a higher power. Then we will take the LCM as we do in all the parts. The LCM will be x minus 1 x square plus 1 its whole square. A will be multiplied by x plus 1 whole square, whereas bx plus c will be multiplied by x minus 1 and x square plus 1. And finally, the dx plus e, the last part of the LCM, it will be multiplied with x minus 1 only. So this step is basically for the sake of LCM. On right hand side, the term will be as it is. And once the LCM is taken, the terms of LCM are cancelled from both sides, with the terms of LCM on left hand side and right hand side both are cancelled. So we will be having the equation a into x square plus 1 whole square plus bx plus c into x minus 1 x square plus 1 and dx plus e into x minus 1. So we will notice that value of x minus 1 can be equated to 0 because it is a linear factor, and this value of x we will put in this above equation number 1. So by putting value of x is equals to 1 in equation number 1, it will give us at least one alphabet, either A, B, C, D or E. So let's put it x is equals to 1. So carefully substitute the value in place of x, write 1 square plus 1. I am writing 1 in place of x. Rest of terms are as it is, just substituting value of x, that is equals to 1. So d plus e and 1 minus 1. So you will notice this part will become 0 because of 1 minus 1, and this part will also become 0. So we will be having only 1 plus 1 square, that is 2 square. It will become 4, and rest of these terms will become 0. So a will become 1 over 4. So it is a value of the first alphabet a. Now we don't have any other linear factor which we can equate it equals to 0. So that's why we need to expand the term of equation number 1. So we will expand for first equation or equation number 1, a time x raised to power 4 plus 1 plus 2x raised to power 2, and then bx plus c. The terms will be multiplied on right hand side, that is x raised to power 3 plus x minus x square minus 1 dx square minus dx plus ex minus e. For left hand side we have x square. So a will be multiplied with all parts inside. It will become a times x raised to power 4 plus a plus 2ax square. Then bx will be multiplied with all parts. It will become bx raised to power 4 plus bx square minus bx cube and minus bx. Then we will multiply it with c. So it will become cx cube cx minus cx square and minus c. And we would have last terms of involving d's and e's. So this is the entire expansion on left hand side, sorry, right hand side. And for left hand side, we people can equate 0 times x4, 0 times x3, 0 times x and plus 0. For that purpose, we will first take up what is common after taking x raised to power 4 common from right hand side. So we will be having one term a raised to power x4, b raised to power x4. So these two terms will be taken. X4 is 4 will be taken common. So we'll be having a plus b. Next will be x raised to power 3. That will be taken as common. So we will have minus b plus c. We will take up x raised to power 2. So that is 2a plus b minus c and plus d. So we are taking common x raised to power 2. And finally we will have the term involving x, that is minus b plus c minus d plus e and the constants. So the constants will be a minus c minus e now by comparing coefficients of x raised to power 4, 3, x raised to power 2, x and constants from both sides, so that we can form the equation. On left hand side, this is x raised to power 4, x raised to power 3, x raised to power 2, 0x and 0. So by comparing, first a plus b will be equals to 0. This will be the equation number 2. Then we will equate minus b plus c equals to 0. Third equation. Then we will equate 2a plus b minus c plus d equals to 1. And minus b plus c minus d plus e equals to 0. And the last term, which will contain constants a minus c minus e, it will be equals to 0. This is equation number 6. So second equations, b will be equals to minus a, and a is just freely calculated. This is 1 by 4. So it will become minus 1 by 4. What from the third equation we will be able to get c is equals to b, and b is already calculated as minus 1 by 4. So from second and third equation, we will be able to get values of b's and c's. We have already calculated the value of a, so now we need to find the value of only two, that is c and d. So for, let's suppose we can calculate the value of d from equation number 4. So putting the value of a, that is 1 by 4, b is minus 1 by 4, and minus c, it will become plus 1 by 4, and d is equals to 1. So we need some simplification. These two parts will be cancelled. This will become half. So d will become 1 minus half. So by calculation, we will be able to get d as well. This is 1 by 2, that is half. Now we need to find value of e. So simply we can get it from equation number 6, which is more simple. So equating e is equals to a minus c. So a is equals to minus 1 by 4, and c is equals to plus 1 by 4, because minus minus will become 0. So overall value of e will become equals to 0. So this is how we will be able to get all 5 values of a, b, c, d, and e. So this is time to substitute the values of a, b, c into the original question to conclude it. Now finally we just have to put the values of a, b, c into the original statement which we made in the first line. Simply substituting the values, a is 1 by 4, b is minus 1 by 4, and c is also minus 1 by 4. So in the first step, we need to substitute the values. That is, a is 1 by 4. So carefully put it like this one. Then b is also calculated as, that is, minus 1 by 4. This is minus 1 by 4, and 1 minus 1 by 4 times x. And c is just, we have calculated above, that is again minus 1 by 4. So we are putting the value of c, that is minus 1 by 4, whole divided by x square plus 1. Then value of d is calculated as 1 by 2, and e is 0. 1 by 2 time of x plus e is 0. Entire term is being divided by x plus 1 whole square. Now we need calculations and the simplification. We have substituted the values of a, b, c. So just understand that these terms of the denominators of upper fraction, because it is a double fraction, it will become as a part of the denominator, means it will be simplified as 1 by 4 times x minus 1. Similarly, minus will be taken up from this part common, and we will have to take up one LCM in the numerator. So it will become x plus 1, because I have taken minus common right here in this position. So it will be like this one over x square plus 1. And again, this 1 by 2 will be shifted in the denominator. So it will become 1 by 2 x square plus 1 whole square. And it is a final and the last step which will give us the answer x plus 1 whole divided by 4 times x square plus 1 and 1 by 2 x square plus 1 whole square. While on the left hand side the question is like x plus 1 x square plus 1 whole square. So after the substitution of the values of a, b, c, we will be able to get the answers. So the important point is this, that we have to after the substitution of values of a, b, c, we need simplification of these fractions which are in the numerators. And the method is this, that we have to take the terms of the upper denominator into, because it is a double fraction, so this 4 will be shifted in the denominator. For this purpose, in the middle term, we will first have to take small LCM, and then we will take up that LCM in the denominator in the next step. So this is how we have to find the answer. We cannot leave the answer directly in this step. Rather, we do need some sort of calculation and simplification, and finally we will write the answer.